Hello guys, welcome to my channel. So today we'll be looking at deep neural network with batch normalization and dropout later. So same with my previous videos, I'm going to skip the first few parts where we'll be loading the dataset. So here you can see that the training dataset will be passed in with a batch of 10 images and the evaluation dataset will be passed in with 1 image. So the first layer is the input layer. So we are going to flatten the image with image height followed by image width. Since this is a colored image, it will be having 3 channels. So the image height is 256 followed by image width, which is 256 as well. So we have already resized the images here, but since we have to indicate the input shape to the first layer, we'll be using the same height and width, and we can name it input layer. Next, to give the flexibility of creating many hidden layers, we can pass in a list of number of neurons. So for each neurons in the list, it will create a new layer. So we are going to use layers.extend. The first layer will be the dense layer with the number of neurons, and we can name it hidden layer, followed by batch normalization. So there are a few advantages to batch normalization. One is it will increase the training speed. Second, it decreases the importance of the initial weights, and followed by it regularizes the model to a certain bit. And also the rationale of batch normalization is very similar to how we scale the images before we fit into the model. So this will also normalize the output from the first layer to the second layer, so that the data input to the second layer is normalized. So for batch normalization, we can put scale to false. Scale is basically the scaling factor. Since value is invariant to scale, we can put it to false. Second is center. Center is basically an offset factor, which is also a bias. Since dense layer already has a bias, we can put it to false as well, and we can name it batch normalization underscore dense. And then we will always use an activation function after the batch normalization. So I'm using value here, and we can also add a dropout layer. So basically, let's say a hidden layer has 8 neurons. What will happen is, if it is 0.5, it will drop 4 of the neurons. So they are basically giving out 0 values. And then we can use layers.extend for the last layer. For the output layer, we are only going to have 1 output, since this is a binary classification, and I'm going to use sigmod as the activation function. After this, we can instantiate the sequential model with all those layers. Before we compile, I'm going to use Adam as the optimizer, followed by the loss function. I'm using binary cross entropy with logic equals to false, and metric is going to be binary accuracy. After which we can fit the model with the training dataset as well as the validation dataset, and I'm going to run it for 5 epochs. If you want to have a detailed explanation about logics, you can look at my previous videos. So now I'm going to train the model with the first hidden layer with 64 neurons and the second hidden layer with 16 neurons. Okay, now, so let's try to view the accuracy and the accuracy and the loss. So we can see that we have a validation accuracy of around 0.53, and the training accuracy of 0.57. This is definitely an improvement from the previous model we were doing. So hopefully this is useful. Thank you. Bye. Please subscribe.